This lesson that we're going to look at here is dealing with polynomials, and specifically we're looking at terms in a polynomial. We're going to start off taking a look at what is a polynomial, how do we describe polynomials, and then we're going to start going through how do we count how many terms are in a polynomial. So the first thing we're going to do is a polynomial is a way to describe mathematical values using numbers, variables, and exponents. Okay. You may have seen these in the past in former or previous classes, and today we're just going to again try to go a little bit farther into what a polynomial is. Now, a polynomial is it's really what the name says. So poly, this P-O-L-Y, poly represents many. Okay, so it's a term that represents many, and nomial represents terms. So a polynomial is made up of multiple terms. Okay, and these terms are then added together to create a full polynomial. Now, the number of terms is different. Could have one term, could have a million terms. There is a wide variety that we could have, but it's going to be multiple terms, and one is represented of multiple. It's just not something that we necessarily go off of always. So what we're going to do is we're going to start off with taking a look at some of the basics. If we think about numbers, just in general, we can describe numbers as a series of blocks. So if we have this little block right here, this is going to represent 1. It's one block. If we put 10 of those blocks together into a nice little stick here, we have a value of 10. We put 10 sticks together, okay, and now we have 100 blocks. And if we put 10 sheets of 100 together, we have a value of 1,000. Okay, you may have done this in the past. These are kind of our these are just little blocks that we can use to represent numbers. If we have less than, so however many tens, that's how many tens we have. These represent place value, right? One's value, tens value, hundreds value, and thousands value. Polynomials are a little bit different because what we do is we're going to deal with variables and how do those variables represent it. So polynomials use variables. Okay, and a variable is a placeholder, okay, which can be any number. Okay, so it's a place value that could be any number. We use variables when the amount that we're using is dependent on something else. So if we're talking about, let's say, the number of kids in the class, well, some classes have a certain number of kids, some classes have a different number of kids. The outcome of whatever the case is going to be on how many students are in the class on a certain day. That could be variable because some days there's more than others. It's just a placeholder right now, so we'll put it in there and we'll use it as an equation later on. Now, this is also a value, as mentioned, which is changeable, okay, or needs to be solved for. Okay, a variable is often dependent on some other factor, okay, which affects the equation. Okay, so when we're dealing with equations in this case here, a variable could be really anything, and we're just going to right now we're going to deal with a variable. Now, how do we describe variables? Well, a variable is shown using, using a letter. Okay, any letter can be used, but some are definitely more common than others. Okay. Our very common ones that we often see are X and Y. These are very common variables which are used quite often, but really any letter can be used, and we're going to be going through using different letters, but I will be using X most commonly, and Y would probably be next, and then every other letter kind of gets mixed around in there. Some I don't use as much because they look too much like numbers, but I'll use X and Y on a very commonly. Now, algebra tiles can be used to represent variables, and in particular, they can be used to represent terms in a polynomial. Okay, and so these algebra tiles will be used to represent variables and as well as the terms in a polynomial. Now, there are 6 different tiles that we're going to be using. There are other ones that we could use, like cubes, but we're not going to do that. We're just going to deal with these 6 right here. So on this left-hand side, you'll notice here we have these light gray tiles, and in my copy of my notes that I actually use, they're yellow, and then we have these dark, almost black ones, and in my copy, they are red. So we're going to deal, these ones here, we're going to say are yellow, and these ones here, we're going to say are red. This little one right here, you'll notice that it's a 1 by 1 square. This one has an area of 1. So we're going to say that this square right here has a value of 1. Okay, and it's a light colored one, so it's going to have a value of positive 1. On the other side here, this same square, okay, it's going to be red or a darker shading, and this one is going to have a value of negative 1. So we have a positive 1 and a negative 1, and we're going to be dealing with positives and negatives when we deal with polynomials. The next one is this stick, which has a length of x and a width of 1. It has an area of x, okay? And so this one is going to represent an x term, so this would be our variable, okay, which is x in this case. And on the other hand here, we have a negative x as it's shaded. So this would be a positive x. This one here would be a negative x. Finally, we have this square here. It's a large square, okay? This one here is an x by x, and if we multiply x by x, we're going to get a value of x squared. So this is going to represent our x squared term, so it's an x to the power of 2, okay, or x exponent 2. This here is an x squared term. Same way, if it's dark shaded, it's going to represent a negative x squared. And so this is going to represent 1 negative x squared. This will be 1 positive x squared. And so each one of these rectangles represents one of that variety. Okay, so we have 1 x and x squared. We have negative 1, negative x, and negative x squared. I'd like you to take a look at question number 1, just on labeling what each of them is and what it represents.